Hooray, welcome to the channel. Let's look at SQL injection. We are continuing in the series for the OAPs. We're looking at the web testing guide, and we're trying to look at some vulnerable applications that we can test to learn vulnerability assessment, pen testing. So for this particular lab, we want to look at a website that is connected to database. Now, what's database? A database typically something that looks like a table that houses information, data in rows and columns, like your typical Excel sheet. And you have websites built in several languages, PHP, ASP, Python, Java, whatever. These applications are going to have some form of database or the other. It can be MySQL server, it can be Oracle, it can be MySQL, it can be MongoDB, it can be Postgres, it can be any type of database. Once an application have a database, what it means is that there should be a way for us to query that database. And how we query the database is using SQL or SQL, structure query language. And because anytime you interact with the database, you are going to be performing some form of SQL, that leads to the vulnerability. So if you don't deploy your application correctly using security principles, it's going to be vulnerable to SQL injection. And the kind of things that are possible are people can create stuff, people can read stuff, information, people can update stuff, people can delete stuff from the database. The CRUD operations, C-R-U-D, CRUD operations. Now, if people exploit that while interacting, it then means our application is vulnerable. So this lab is going to be in two parts. We're going to exploit SQL injection vulnerability. Then we're going to research some SQL injection mitigation. Because tools, techniques, tips, countermeasures should be at the heartbeat of what you do as a security analyst. So you shouldn't tell us that something is vulnerable and you can't tell us what to do to secure that particular stuff. Okay, we need the ethical hacker machine, then we need internet access. So I have my Kali already logged in, right? It's already logged in. So I will just go to my browser and navigate to this URL. I will go to Chrome browser, right? So this is, okay, I think I already logged that. So in your case, once you log in, you're going to find something like this. So if you come in, you're going to find something like this interface. So this is the damn vulnerable web application. So this application is vulnerable. That's why it's called damn vulnerable. Very, very vulnerable. Now, enter the credentials, admin and password. Set DVWA to low security. So you can do that by coming. So currently now the security is low. If you want to change that, I think you go to setup. You come to is it instructions? Okay, not instructions. Let me check. Home. Where did I change this? Just a while ago. Left pan, and I go to, I think it should be in setup. Right. So here you could create or reset a database. Let me look for that shortly. So I think you go to DVWA security, right? It's currently low. So you can toggle between low, medium, high, impossible. So when you set it as impossible, you are setting this application to a very high security standard. So when you're attempting your test, it's going to be very difficult for you because most of those vulnerabilities have been patched. If you keep it low for a beginner, it makes it very easy for you to be able to commit and implement some SQL injection vulnerabilities. So you see the explanation of it, the different types: low, medium, high, impossible. So we keep it at low and we submit. Once we've configured it to have a very low security level, the next thing we're going to do is to click on SQL injection. So there are several things you could learn using this application as a pen tester. So a pen tester will want to learn how to brute force, how to do command injection, how to do cross-site request forgery, how to do file inclusion, add files to a server and or application and upload, an update, file upload, insecure capture, because you can have capture and it's insecure, or maybe using an older version. SQL injection blind. There's difference between the both of them. This one is when you are doing SQL injection, but it's actually not giving you any reply. So you actually have to like guess to know if it works or not, or maybe because of the response of the server. So that's the difference between your regular SQL injection and blind. Of course, you have cross-site scripting, the XSX, both reflected and stored. Okay. Our interest here is SQL injection. Now, we have an attack surface. So what's an attack surface? So an attack surface are all the inroads into your web application. So, and that's where people can actually attempt. Maybe your login page, your forms, on your URL, where people actually maybe upload the document and all of that. So if that application is not coded properly, it makes it vulnerable to SQL injection. Now, if you want to be comfortable with this lab, you can try to read up on SQL, how to do select statements, how to do union statements, how to do conditional statements, how to run some of those basic SQL commands. This is going to come handy because you are actually trying to interact with the database. Okay, we'll keep it very simple. First thing we want to do is we want to say this. I'm going to explain each of them so that you understand it. Now, when you say this or 1 is equal to 1 hash, what you're trying to say is that you want to, if I type username and I say 5, I'm telling this particular application to check if there's a user ID called 5. If there's none, it's going to return and say there's no user as 5. But what I'm trying to do here is I'm trying to escape all the other, make the other end of the SQL query useless, and now put a conditional statement by saying or 1 is equals to 1. Since 1 is always going to be equals to 1, if any application returns a result, it then means that application is prone to SQL injection. Because 1 is always equals to 1. If it runs, it then means that that application was not checking to have countermeasures for SQL injection. You should receive an output which will show something like this, right? We have admin, we have Gordon Brown, we have hack. So we just have some list of users. So just going to pull out all of the first name and surname of those users. So you've entered an always true expression. You go to an e-commerce site like Amazon, Jumia, Alibaba, AliExpress, DHgate, Best Buy, any e-commerce website, and you want to purchase something and you type watch. What you're trying to say is that please get me all the content on this database that have the string what? Watch. If on that search bar you type, what was it called? An apostrophe or 1 equals 1, you put a hash and you enter. If it returns any results, what it means is that they didn't check to have countermeasures for SQL injection. So let's check for numbers of fields in the query. So in the user ID, I will just type this. You can just go through this with me. Right? You see, I have admin. So you receive this for the user 2. I'll just run the same thing for 2. I'm trying to get 2. So what am I doing? I'm running an SQL statement. I am now trying to order my results. So in SQL, you can do select statements. You can do ordering. That means you can do ascending or descending order. right? You can also check the last one. So let's see what this is going to give us. So you see now, unknown column, right? So let me say SQL select statement table. So let me just show you a simple example. So what it means is that it has thrown up an error message. So there's two things here. One, the website is prone to SQL injection. Secondly, the website is not even handling the error messages properly. Normally, it shouldn't come back and tell us, oh, there's no column. That's why you see some websites where you try to log in, you put a wrong username and password. It won't tell you if this username is in existence or not. Or if you put a correct username, put a wrong password, it won't tell you why you're not able to log in, whether it's the username or the password. Because it doesn't want to reveal that information to you. Because the much information you release back to the attacker, you make him understand the system and, of course, how best to now counter the system. Okay, I'm trying to show you something just to explain some of these statements. Oh, this is very tiny. Okay, let me just write on. Okay, so because the third string return an error, this tells that the query involves only two fields. So we just have only what? Two columns. What are the two columns? Right? First name and what? Admin. And of course, the integer, that is 1, 2, 3, 4 in that particular table. Okay, the next thing is for us to check for database management system. Now, remember I told you have different database systems, you have different languages. If I want to know the version, you could try this out. So it's going to return that this is running a MySQL version 5.5, right? Now, you see it returned all of these, and at the end, it gave this out. So it just tells you that it's running DBMS, Database Management System, MySQL version this. Now, the question is, what are the vulnerabilities of MySQL version 5.5? Now, a database system shouldn't tell us the vulnerability that's running on, because that's too much of information. Determine the database name, of course, 5.5.58. That's what you have here. The next thing is we want to determine the database name, right? So we could run this. Now, what are we doing? Here, we ran a union statement in SQL. The first thing was to check if 1 is equals to 1, then add to that, we now select and check the version. For this very second one, we are checking 1 is equals to 1, which is always going to be true. Then we're now also checking as a union statement. Also now checking to check the what? Database. So I'm going to run this and submit, right? DVWA, damn vulnerable web application. If you use SQL map on this particular application, yes, you can actually tell all of these details. You can dump the database, you can dump the table and all of that. So we're going to do that in subsequent labs. Okay, so retrieve table names from a DVBA. So what you're trying to do here is to run this string. So let me explain. This is always true. Then you are adding to select table name from information schema table. Of course, this is the database, or rather the schema for this particular database. Let me see if I can open a MySQL database shortly. Just a second. Okay, so I have XAMPP on this system. So XAMPP is cross-platform Apache, MySQL, PHP, I think, and Perl. You can use this if you need to do any local development. If you have your cPanel, control panel on a web application, you can go to your cPanel and get to your phpMyAdmin. So I'm here. I'm going to admin. So once I click on this, it should take me to page member admin. Once it takes me there, I'm going to show you like what we mean by information schema table. Like how in your database, how does your table look like, right? So you know your database is going to be a reflection of everything you have on your application, right? Okay, so why that loads? So it just tells us that you want to take you want to know the table name from that, and the table type is base table, and the table schema is what? DVWA. It's just going to pull out that information, right? So I will just cancel this and run this here, maybe. Okay, so I'll run this command, this entire command. I want to retrieve the table names, because all what an attacker will try to do is to get your type of application, get the database type, get the database name, get the table names, and the person can get the content of the table, right? So I will run this. So you see, I have the entire table, right? Everything. So this is a very simple example of another vulnerable application. Are you seeing information schema? That's where it's coming from. Because that guy holds all the databases, right? If I open this up, let me collapse this, open this up and just. If you click on information schema, right, it holds the information about all the content, the table, the database, and all of that. And these are all the databases here, right? Right? Holds the database, the columns, everything you have. So it holds all of that information. Same thing with a simple database like this, right? Are you seeing? I can create a database this. I can create a table name called students. I can say it should have 3 columns, right? If I create it, I've created a table inside the word, a database. I can give them names. I can say the first person is Maxwell. Name, then course, then gender, right? So that's my, what's it called? That's my table names, right? So I'm going to have integer. I can say, okay, this is integer. The length is going to 255 characters, or rather my column names. The default is going to be none. I can keep this, or I can just make this course and name, and I can make this ID. And I can also make this auto incremental so that it's going to count. The first person is going to be 1, the second person is going to be 2, third person is 3, like that. And I can say, okay, this length is also 255, no default, and this is going to be the primary key, and I'm going to save. Right? You see, I have a database. I've created a table name called what? Students. And my table name have what? 3 columns: ID, courses, and names. So what an attacker would try to do is to do what? Is to get the database type, the database name, the database table, then the database content. This is the database, logistics DB. These are the different tables, and these are the contents. So for every database-driven application or database-driven website, they're going to have a database, they're going to have several tables, and those tables are going to have what? Content. So an attacker is after the what? The content of the tables in the what? In the database. Okay, so let's move on. So you see, it has enumerated the ID, the first name, the surname, and all the content you have in the database. Okay, so it found guest book and users, right? Guest book and users, those are the two tables that it found. Just like in this case, I said we found, right? You see this database, it has how many tables? 1, 2, 3, 4. If I click on offices, it just has all the offices, the address, the city, the phone number. If I click on another one, Korea, it has what? All of that information. If I click on another one, it has all of that information. This is a very vulnerable application. You see the passwords are in plain text. That's to say that if the password for an application is even encrypted, if an attacker gets hold of it, he can attempt to start doing what? Reverse engineering, to start decrypting. Okay, so let's move on. Let me collapse this. Okay, now, which table do you think is the most interesting for a penetration test? It is what? Users table. Because that's what we're going to have, the username and passwords, right? Just like in this vulnerable application, if you see all the tables here in Korea, Korea officers, Korea track, offices, it's actually Korea officers. That is the user that is of most interest, because that's what have the officer's name and their password. True or false? But you see the Korea, of course, that's also important, but not so much important because it doesn't hold things like credentials. Okay, so let's move on. So the retrieve columns names from the user table. So we still run the same thing, still run this one. It's going to grab all of this information from us. So this is a very simplistic way to attempt. Okay. Okay, this list, the column names displays after the listing of user accounts in the output. Explain. So the user columns, that is this one, and the password column are of interest because they seem to contain information. Okay, I think I didn't run this correctly. Let me run this again. Okay, good. So are you seeing? So it has the username and the password. Username, password, right? Or first name, surname, right? So this is of a great interest because even if it is encrypted, we can extract it and try to start doing what? Reverse engineer. Okay, the next thing to do is to do what? Is retrieve user credentials, right? So I could run this. And you see, it's going to have all of this, the username, and of course, the hashed password. The next set of things we're going to be doing is to say, can we know what kind of encryption is this hash? And try to get back to know the what? The plain text protocol or the plain text for that particular hashed password. Okay, so the next thing we're going to be doing is, okay, what is of interest now is for us to start doing what? Hacking this particular hashes of seen. So there are several tools we can use. We can use the crack station. We'll go to crack station. We can pick this particular one and try to know what the password can be. So copy and paste the password hash from DVWA into crack station and click on crack hashes. What's the password for the admin account? This is the admin account, right? This is the hash of the admin, right? So we can copy this, paste it into crack station, right? And crack hash, if it gives us a green, it then means that it has cracked it. What's the password? The password is what? Password. And they are using what? MD5. Now, that's one good thing about password salting. So password salting is going to add something before it tries to like encrypt or before it tries to hash. So it offers an additional layer of security. Instead of just saying, okay, this is the encryption or hashing algorithm. Once you have this, you just encrypt. What will happen is that if somebody gets the encrypted item, the person can do what? The person can go back. So password salting, password peppering, this adds layers of security. And this crack station supports what? LM, NTLM, MD2, MD4, MD5. So if you're using any of this encryption, though you are encrypting, your password is hashed, your password is in ciphertext mode, they can still be what? They can still be hacked. So that's why using very recent, very updated hashing algorithm is very important. Okay, so password. What's the password of the user? Pablo. This Pablo, this is his hashed version. Oh, password that raised up her head. I have some students in class here, so somebody answers Pablo here. We have this. I'm not a robot. Right? So Pablo is what? Lets me in. So if you check in here, that's the answer. So quite some reflection here. One thing you can do to prevent SQL injection is to prevent SQL statement. I think maybe in subsequent class, in the subsequent session, we can build a small blog, a PHP MySQL or Python based blog or ASP blog. One is going to be vulnerable, one is not going to be vulnerable. And you're going to see the difference in the code between the vulnerable application and the non-vulnerable application. That way you understand how to create an application that is what? Vulnerable, or how to test for an application that is what? Vulnerable. So what should you be doing if you want to make your website not vulnerable? Check for validation. So you must check what input the user is putting into your fields before you send it to the database. Take, for instance, if we check for all of those strings like semicolon, equals to, we don't want those kind of strings into our what's it called, entry fields. If we see them, we drop them, because those kind of fields, all of these fields you have there, things like select statements, union, equals to, we don't want all of those kind of things in our fields. If we see them, we just drop that command. We don't even send to the database. That's input validation. That's one way to make sure that you mitigate that. Prepared statements, input checking, field validation, filtering user inputs, right? All of these are the ways you can do what? Protect your application. I think that's the end of this very exhaustive lab. So we just use DVWA on a low security measure to learn how to perform SQL injection. Have questions, have more labs you want done, you can drop it in the comment section.